Okay, I hope most of you guys are here. Let me see, admit. Okay. So yes, so I'm your instructor. My name is Adit Doza. I'm your professor for this course. Um, so welcome to BA3400, section 8. Okay. So today I'm going to review the chapter 9 and chapter 10 for our midterm, right? And I have given you guys instruction on how to take the exam using the lockdown responders browser, and I have uploaded a practice test. So the practice test is not graded, it's only like 3 or 4 questions, and it's just for getting you accustomed to the like exam environment. Okay, so make sure you do that before you actually attempt the midterm one. Okay, so the practice test is named as practice test in the quiz section of our course. Chad, let's see how many questions are there. Okay, there will be total 55 multiple choice questions. So let me start with the review of chapter 9, and you guys can make a cheat sheet or a crib sheet. It should be double sided, and all of you should have webcam in your laptop. If not, you should order one, because
Sorry to cut you off, but there are only 55 questions, right?
55 multiple choice questions, yes.
And you said we're allowed to make a cheat sheet. Are we allowed to have any other devices like our phone to scroll through?
No phone allowed. You can keep your scientific calculator, your crib sheet, and the webcam should be on. So basically the webcam will monitor your like all of you guys. So our department has, it has been done actually from last semester. It's nothing new, because all the classes are now online.
Okay. Are we allowed to print out the handouts and have them with us? Like, are we allowed to have as much paper as we want out?
No. Unfortunately, you cannot like have the handouts with you guys. Okay, so I will go through the review session. Why you need the cheat sheet, you will know, because memorizing the formulas is not an easy task. So you better write down all the important formulas. Okay, so only your you can have your 2-page crib sheet, your scientific calculator, and pen and paper, and maybe like 1 or 2 pages of like rough page to do your maybe rough work.
Can I ask a question, please?
Yes, sure.
We talked over email last week, and you said that you might allow us to have hard copies of our Z and T tables in front of us.
Yes. So the Z and T table, those you can print it out, because sometimes the screen is like too small. It's not easily like, you need to zoom, right? So I think it's better you can have the Z and T table printed out. Okay.
Okay, and then are we supposed to show off like what we have in front of us before we take the exam?
Yeah, in the screen, like they will ask for your ID,
Okay.
and it will give you instructions basically.
Okay.
Okay.
Thank you.
Yes. So how many of you are new to taking the test online? How long do we get on the test? So the test is 2 hours and 30 minutes. So 150 minutes. Okay. Some of you are new. Okay. Don't worry about it. Do the practice test. I mean, once you attempt the practice test, you will have an idea like how the exam looks like. Okay. So let's just start our revision, like the review. So in the midterm, total 55 questions. Okay, so let me start reviewing 55 questions total. So basically chapter, you guys need to know the introduction, where we have posted the introduction lecture. like um, it's like a recap of the BA2300, right? So you guys need to know the notations. What does mu mean? It's like a mean of a population. Sigma means the standard deviation of a population, okay, and S means the standard deviation of a sample. Okay, so you guys need to know the what each notation stands for. Okay, basically it's like what you guys did in your previous class. Okay, so the notations are important. There could be 2 or 3 multiple choice in the midterm. Okay.
Hey, Professor.
Yes.
I believe there's a few students that are trying to get into the Zoom call. I think they're in the waiting.
Few students are in the waiting. Okay, I'm admitting all. Okay, you're welcome. So the notations are important. So you guys need to know all these notations for the exam. Then the next step is the hypothesis testing process. Okay, so what is it about, and what are the logic of the hypothesis test? We have covered this in our like lectures, right? So you guys know how to formulate a hypothesis, right? How to calculate the test statistic, and the decision making rule, whether to reject or whether to reject or not to reject the null hypothesis, right? And the fourth step is the interpreting the hypothesis test. Okay, so these are important. Some definitions, like what is a mean, what are like standard deviations, so these are pretty standard. We have covered this in our lectures. Okay, what is a probability distribution? Then you guys should know like how to which are the probability distribution, like for this example from 18 to 26. So this is the probability distribution in this range, right? So pretty much that's what we need to know in the like chapter 9 part 1 or the handout 1. For handout 2, you guys should know that how to set up the lower tail test. Okay, the different setup. So if the true population mean is less than a given number mu naught, then the formation is in this form, right? So we have also covered this in our chapters. So let me just see if more people are waiting. Okay, so that's for if it's a lower tail test. What about an upper tail test? So if the population is greater than a given number, then the upper tail test is in this format, right? And for a two tail test, it's if the true population is different from a given number. So this is why I'm emphasizing on this, is because there will be a question, either upper tail, lower tail, or a two tail test. Okay, so there will be one question about a single population mean.
So what do you mean that, like, the question about a single population mean, like, to identify whether it's lower tail, upper tail, or two-tailed, or like how will we have to apply that?
So in the question, there could be like a hypothesis, like if it is greater than, like you are assuming if the mean is less than a certain value, so then it would be a lower tail test, right? If your true population mean is less than a certain given number. So based on the question, you need to know which test it is, right?
Okay, so we just need to identify which one.
Exactly. Yeah, exactly which one you need to use. And not only just the setup, because setup is only step 1 of the hypothesis, right? So after the setup, you guys need to calculate the test statistic. And if you know the sigma, which is basically your standard deviation, you know that is a z test statistic. So let me just highlight some of the important formulas here. So let me use my snapshot tool. So of course this formula is very important. If sigma is given, if you know sigma, right? So let me just paste it here. So maybe this should be in your cheat sheet. Okay, it's one of the important formulas that I think you should definitely have in your cheat sheet. So you guys need to know what are each things. X bar is the sample mean, mu naught is the hypothesized value, sigma, if it is given, then it's the population standard deviation, and n is the sample size. Okay, so you can write it down in your cheat sheet the way you want. If we don't know sigma, we have to use then the sample standard deviation. So sigma is the population standard deviation and S is the sample standard deviation. So in that case, we have to use t distribution, right? So let's use this formula as well. So this is the second one. So this is how you should write your formula cheat sheet. So here, if sigma is known, okay, if it is known, then we use Z, and t distribution we use when sigma is unknown. Is it clear to everyone?
Yeah.
Okay, good. So one more thing I would like to point out, because many of you guys make the silly mistake. When you do the t distribution, remember that the degree of freedom is always n minus 1. Okay, some of you guys forget to do that and then you get a wrong answer. So remember this as well. Okay, so that's about the handout 9.2. Then the step 3 is the rejection rule. So how do we reject? We can either use a p-value approach, okay, or we can use a critical value approach, as we have done in our lectures. So p-value, if it is less than alpha, in a lower tail test, also in an upper tail test, if p-value is less than alpha, we reject the null, which is the h naught, right? For a two-tail test, we use 2t p-value, okay, the two-tail p-value, right? So we have done pretty some of the examples, which I will actually show you guys. So p-value approach you can use, or you can use the z-value approach as well. So these conditions you can write it in your cheat sheet as well. I mean, in short form, it's all right to write it there. So that's for the z-test statistic. And for t-test statistics, you will see that they are actually very much identical. So p-value approach exactly identical to the z-test statistic thing. So this is the decision making rule, the step 3, whether you reject or do not reject the null, right? So you can do that. So, and the last step is the interpretation step. I have a question about chapter 9 assignment. Okay, I will cover the the assignment questions later. Okay, let's finish the review, then we can talk about the assignment question later. And the mind type questions, by the way, will not be in the exam. Okay, so don't worry about it that will we get the mind type of questions in the exam? No. So these are the conditions. So that was for a single population mean, right? We also have something called single population proportion. Okay, so we did that as well in our chapter 9. So this is the lower tail test. If the true population is less than a given number, then we use this type of format. If it is greater than a given number, the true population proportion, the format is this way, right? And if it's a two-tail test, then the format is so on and so forth. Important thing to note is you need to know the proportion z-test value, okay? So for the proportion z-test value, so let me use the snapshot tool again. You can include it in your cheat sheet.
So what is the difference between this z-test formula and the other z-test formula?
So the main difference is the parameter. So one is called the mean difference, another one is the proportion difference.
What is this one called?
this one is called the proportions. So if you have watched my lecture videos, so proportions is usually ranges from 0 to 1, right? And if it is in percentages, then what do we do? Let's say if it is 95%. How do you calculate the proportion in that case? Anyone want to volunteer? 95%, so divided by 100.
Use a scientific calculator.
No, I mean, if we want to use it in a simpler form, just divide it by 100, right? 95% divided by 100, it's 0.95. So I will show you guys some examples. Okay, so let's write this formula here. There are worked examples as well. So the proportion test also have the decision making rule. You guys know when to use the decision making rule, and there are certain assumptions. Okay, so you guys need to know the assumptions. Okay, we have covered all of them like in our lecture notes and lecture videos if you guys have watched it. So let me show you guys some proportions thing as well. Okay, so these were the worked out problems. So let's go to, okay, I will show you guys the proportion problems a little bit later because I have something else to cover as well. So these are the worked out problems that we have done in class. So it's a, if it's a lower tailed or an upper tailed, so this is an upper tailed example, right? So let me highlight this example of an upper tail, right? This one is an example of a lower tailed example. Okay, and two-tailed, you know that it's on both sides. Okay, two-tailed test. So we covered that in our lectures as well, right? So these are pretty much similar in nature. Okay, I'm not going to solve each and every problem here because it's just a review class. So if you have watched my lecture videos, like most of them, like I have covered like what are the critical things. So another important thing is know how to use the critical values, right? So for alpha 0.05, the critical value would be 1.645, right? So you guys need to know how to use the critical values and what are the critical values for each, like for z of alpha, right? Let's show, yeah. One more thing I want to point out is another mistake that students often make is like when you have a two-tailed critical value of z of alpha. Let me actually highlight this. You actually need to split the alpha by 2. Okay, many of you actually don't do that and then make a silly mistake there. So when it's a two-tailed critical value, we always divide it by 2, right? So basically, even if I am saying 0.05, but you actually have to look at 0.025. Okay, so that's why the critical values are 1.96 to plus 1.96 to negative 1.96. But if you don't divide, then you will incorrectly assume it's 0.5 and then you will write 1.645. So that would be a mistake. So you need to read carefully that whether it's a two-tailed critical value or an upper tail or a lower tail. Okay, is that clear? These are like basics, basically pretty much basics. If you guys have watched my videos and did the worksheets, it should be pretty clear by now. All right. So you guys know how to set it up, like a lower tail test, upper tail test. Lower tail, always see the alternative hypothesis is less than, okay, less than a given number. Upper tail, you will see that the alternative hypothesis is always greater than. See the sign, okay. So this is just a recap of all the theories. Two-tailed is equal to and not equal to, basically. Right, so setup you guys already know. So let me just move forward a little bit. I want to show you guys the proportion test. So this is an example. So page 23 of chapter 9. So I will post the slides as well. So maybe this is very important. I will give a similar problem like this, maybe, and you guys need to like identify. So you have to read the question. You need to know like how to formulate. Is it an upper tail or lower tail? So this is an example of a single population mean. Okay. So one of you asked me what's the difference between mean and proportion. So mean is the population parameter here, right? We are talking about means. So the mean example is this one. So another example which is similar, this is a two-tailed test. Okay, so when we calculate the two-tailed p-value, let me see if anyone, two-tailed p-value, always remember you have to times the p-value by 2. Okay, for critical value you divided the significance by 2, but when you calculate the p-value you times the p-value by 2. Okay, so these are the distinction. So pretty much a basic concept, right? I am highlighting this portion so that you guys don't make any mistakes in the exam. Okay. T distribution, when we don't know the sigma, you have to know these properties, the properties of T distribution. It's pretty much similar to the Z, right? But except that it is not normal. Okay, but Z distribution is normal. But T is similar but not exactly like a Z distribution. Okay, and T distribution, they have different critical values, and another thing is they have a degree of freedom. Okay, always they have a degree of freedom for a T distribution case. Okay, another thing, like
I have a question real quick about the last point.
Okay.
You said like the two distinct differences about the T distributions are that it always has a degree of freedom, and then what else was different?
And it's a not normal distribution. It's not normal, but Z distribution is normal. Okay. Another thing that you guys need to do is like, see in the midterm exam, because these are all multiple choice questions, I can ask you, like, let's say I give you like this problem on page 27. I give you the alpha significance level, I give you the degree of freedom, and I give you the test statistic. Okay, basically if I give you all three of these, and then I ask what is the p-value. Now to calculate the p-value you will need Excel, right? But without Excel, if I want you that what is the p-value, you guys can actually give me this Excel formula that it is t.dist, then you write the critical value here, then degree of freedom here. It's not critical value, the Z test statistic basically, and then true. And why true? Because it's a lower, it's on the lower tail, right? So that's why you have to write true. So that's how you will find the p-value. So you don't actually need Excel in the exam. So in the multiple choice, if you see something like this, the t.dist 1.5738 true, you know that I'm actually asking for this. Okay, because if I don't give you Excel, you cannot find the exact 0.1272, right? You can't do that, but at least you can find this part. So you need to know that which one you should use for which case. So this is for a lower tail test. If it's an upper tail test, you have to times it by 2, right? So you get the idea like how I am asking for the p-value. Okay.
Wait, what do we have to multiply by 2 for the upper tail test?
See, for an upper tail test, if you have to do a if you have to calculate the p-value, right, you need to multiply it by 2, right, for p-value.
Gotcha. Okay.
Right, so it's important. Page 27, there could be like 2-3 problems like this, like calculate the p-value for certain but you don't know the sigma, so it's a t distribution, but I will give you degree of freedom and I have to give you the z test statistic. All right, then you can say, oh, the two tail p-value is this. If it's a one tail, lower tail, it's like this, right? So it's very simple in that sense. So far, are you guys following what I am saying for chapter 9?
Yeah.
Okay, that's great. If we don't know sigma, then we use S because sigma is unknown. I'm highlighting this proportion as well. And I told you guys many times, you guys forget to subtract 1 when you are trying to find the t degree of freedom. So don't make this silly mistake, and that's why sometimes you are getting like you're making mistakes in the exam. So you can either use p-value approach. Why we used rt because it's a upper tail. So when it's an upper tail, so important thing to note, when it's upper tail, we use t dot dist dot rt, right? Upper tail. Right? Lower tail, we don't use dot rt. We just use t dot dist function, and then like usually here you write the test statistic. Here you write the degree of freedom, and here you write true, right? So here you don't write true when you're doing an upper tail test. And right now, let's talk about the single population proportion. So someone asked me about the difference between mean and proportion. Mean is talking about the mean, and proportion is basically what is the percentage as a proportion. Review questions for exam on. So we will have the basic idea. Okay, see, I will give you guys something like some practice questions. How about that? Okay, instead of giving you yes, so I will give you guys some practice question on chapter 9 and chapter 10. But in the in the review session, I am actually giving you guys some hints like what you are. Okay, you are welcome. What you guys are going to expect, and I want you guys not to make any silly mistakes in the exam. Okay, yeah, sure. So see, proportion, you always have to like convert it into this in between 0 and 1. See, I have already highlighted this part, right? So you have to divide it by 100 if it's a percentage, and if it's a fraction, you divide it by the largest number. So 25 out of 72, so you divide 25 by the largest value, which is 72. So proportion is always between 0 and 1. Okay, so when you are calculating your proportions, another silly mistake many students make, proportion should be always between 0 and 1.
Hey, Professor.
Yes.
Did you also read that lower tail distribution formula? I'm not sure what that's supposed to be before degrees of freedom.
Oh, this would be the test statistic, okay? The t-test statistic that you will have.
Gotcha.
That's the form. For an upper tailed Excel p-value, so this is when we actually calculate the p-value in Excel, right? In Excel. But because I am not giving you guys Excel in the exam, you have to write something like this: test statistic, whatever it's given in the question, and degree of freedom. So this is for the upper tail test. This is for the lower tail test. Okay. Yes, is being okay. Yes, it's recorded. That's great. So proportion, that's how we do it. And let's look at one example here. Okay, uh, these are only like the partial proportion example, but there is a full worked out example. So make sure you guys do the page 27 of this review. Okay, very important. I'm saying you that because that question might appear. And this one is page 31. This is how you set up the question. Okay, let me magnify a little maybe. So Omen's triathlon, the problem that we did. So here it's the hypothesis is that the proportion is 30% of the race entrants are women. But in their sample they found 57 over like 151. So I always divided with the largest value, right? The p bar. So you have to get the p0 and the p bar. Why you need the p bar? Because you need the p bar to calculate the z-test statistic. Okay, so this is the formula. So I have highlighted this formula here, right? So this is how first you set up the problem that they assumed hypothesized that it's equals to 30%. Right, it's 30%, so the alternative would be it's not 30%. That's fine, that's a very easy setup. Then you calculate the z-test statistic, which is the second setup, and then you make the decision making rule. So you got a z-test statistics of 2.08, and your alpha significance is 0.1, right? And since it's it's a two-tail test, we have to divide alpha by 2, right? Two-tail test, if you use critical value approach, always divide alpha by 2, right? So 0.05. So at 0.05, critical value is 1.645 and our z-test statistic is 2.08. So it actually falls in the rejection region, right? You guys need to know where is the rejection region. So rejection region is on both tails because it's two-tailed. So one would be the positive 1.645, other would be the negative 1.645, right? And our z-test falls in the rejection region, so we reject the null. What's the null? It's that p equals to 0.3. So if you reject the null, that means you are what? Accepting the alternate hypothesis. That means p is actually not equal to 0.3. So that's your interpretation, right? So we reject the null, we accept the alternative, okay, and we can conclude that actually the proportion is not 30%. So proportion of population is not 0.30. Okay, so that's a very easy setup, very simple. We did this in our problems, right? And lastly, for the last part of chapter 9 is the type 1 error and the type 2 error. All right, so what is a type 2 error, or what is a type 1 error? When the null is true and you have rejected the null, that's a type 1 error. And when the null is like false but you didn't reject it, that's a type 2 error. Okay, so you guys know like what's a type 1 error, type 2 error. I will have 4 multiple choice questions based on type 1 error and type 2 error. You guys need to know this. We have done some problems. You can actually copy this flow chart in your cheat sheet as well. Okay, maybe I should use the snap tool here. Make sure you create your own cheat sheet. Okay, so that's important. Let me take it up. Maybe okay. So this diagram will help you like whether it's a type 1 error or a type 2 error, or if it's no error, okay, so and so forth. So that's about it actually for the type 1 and type 2 error, probability of making error. So you can look at the videos that I have, in my lecture videos, okay, whether we have made a mistake or not. All right. So that's about chapter 9. Any other questions regarding chapter 9? Any questions? Okay. Okay, you are welcome. Okay, so that's chapter 9 part. So now let's start the chapter 10. So let me close this part. Chapter 10 combined.
Actually, I have a real quick question. I just saw the worksheet, the type 1, type 2 error. Which worksheet is that? Because I don't think I have that downloaded where it had all the problems of identifying type 1 and type 2 errors. I think you were just on it.
Okay, so that worksheet, let me go to my Zoom.
I have it right in front of me if you just want me to tell them.
Yeah, you can tell.
Yeah, it's chapter 9, handout 9. I just had it right in front of me. I thought I'd save you the time.
Okay, yeah, that's great. Yeah, it's handout number 9.
Thank you.
Yep. Okay, thank you, guys. So let me do the chapter 10 review now. Of course, notation is important, just like the chapter 9. You need to know which one is the population and which one is the sample. So usually, let me teach you guys a trick. Sample one usually have some kind of bar in it. Usually those are the you can easily know that these are sample mean or sample proportion if there is a bar. Only for the standard deviation they are denoted by S1 and S2. Okay. So in chapter 10, now actually we will do difference between two means. So in chapter 9 it was only difference of one mean. Now it's like two mean. Okay. So it was for a single population mean, not one mean, but single population mean. Now it's actually two population mean. So the setup is exactly like similar, but right now it would be mu1 minus mu2, and by default usually we assume d to be 0 if nothing is given or specified in the question. Okay. But if I specify, then it could be different. So for a two population mean, the z-test statistic would be different. Of course, it's different. So you guys need to know this formula as well, right? So this could be an important formula that you guys should know. Oops. And one more thing, a good habit is to write it down that this is for difference, okay, of two population means. Okay. So it's easier to identify which one are you using for which case. So let me. So the previous one is for a single population mean. So this is for single population mean. Okay. And if it is unknown, then we use the t distribution. Okay, so t distribution is this one. If the sigma is unknown, so we use S1 and S2. Not only that, you actually have to calculate the degree of freedom too, and this is the most tedious part. Okay, so this is when sigma is unknown. So when sigma unknown, here sigma is known. But not only that, you actually need to calculate degree of freedom for t-test statistic, right? So degree of freedom, this is the tedious formula, but fortunately I haven't given this in the midterm. Okay, I don't want you guys to waste your time, not waste your time, but it's a tedious, like you will take a lot of time to solve it. So I will give you guys the degree of freedom, you don't have to calculate that. Yes, you're welcome, Jai. And actually Jai actually asked, it was in exercise 10.2 for our mind tab, right? Let me see, this is in mind tab chapter 10. I think it's 10.2 probably. This question you have to calculate your degree of freedom, right?
Okay.
Yeah, but you can do it easily using Excel. So it's not a big issue. I'm not going to ask you to calculate it. I will probably give you the degree of freedom in the exam if I give you sigma unknown for two population mean. Okay, so if two population mean, and the conditions again very identical. These are similar, like once you get the p-value approach, okay, the conditions are pretty much similar. All right, you guys can write down these conditions if you want. For z-test statistic, we also have conditions for t-test statistics, right? So I'm not repeating again. And in the exam, actually, I will assume D to be 0. Okay, in the exam, I didn't give a problem where D is different than 0. So I have simplified your exam questions in a way. Okay, so this question will definitely come in the exam. Okay, a difference between two population proportions. I actually have asked two questions, not only one. I have asked two population proportion questions. So there will be 10 multiple choice in total. Okay, 5 and 5, probably 10 or 12 around there. So I don't exactly remember because I submitted the questions like long time back. But definitely two of them would be coming. And this one, page 9. So why I gave two for our two population proportions is because this problem is a little bit complicated. Why it is little bit complicated? Because first you actually have to find when we get partial credit. It's multiple choice question, to be honest. So it's just, there's no partial credit in the exam. But I'm telling you something like, let's use, you guys need to know the pooled estimator first. This is two-step process. Once you know the pooled estimator, then only you are able to use the z-test statistic. Okay, so not only you can set up the question, but to calculate the z-test statistic, you need to know both these formulas. Okay, so that's why this question is worth more points in the exam. If the question is two parts, when will we yeah, even if it is two parts, see, there will be like I can ask what's the pooled estimator, right? Or I may not ask as well, because I assume that you know that for two population proportion difference, it will be pooled estimator, right? So yes, so basically there is no partial credit, because if you don't get the first one correct, you won't get the second one correct, right? Because it's interdependent. Okay, So as I was saying that this formula is important. Let me write it down what it is. Difference between two population proportions. Okay, you need to get this step first. Once you get this correct, then you can get this correct, because you have to use the p bar, the pooled estimator here. P bar is used in the where it's used in the denominator, right? So that's what I'm definitely going to ask. So page 9 and 10 of chapter 10.
But the p bar is used in the top formula as well.
No, in the top that's P1 bar and P2 bar.
P1 bar and P2 bar is different from p bar.
Yes, because that's the trick, right? The P bar is the pooled weighted estimator. So P1 bar, P2 bar you calculate from the question. Let me show you a problem, then you guys will know what I'm talking about. So this problem you can do page 13. This one the easiest one. It's two population mean problem, okay, not the proportion problem. Let me just use this highlighter. Okay, this is when sigma is unknown. It's again two population mean problem here as well, right? But sigma unknown, and here you have to calculate the degree of freedom. But I told you guys that I will give you guys the degree of freedom. Okay, I'm not going to make your life complicated. Okay. But for the proportion problem, here page 19 of chapter 10. Oops, what happened? So page 19, first you have to calculate P1 bar, then you have to calculate P2 bar, right? How? Like you divided by 100, because these were given in the question in terms of percentages, but you have to convert them into the proportion, and then you calculate the pooled P bar. Once you calculate the P bar, see the P1 and P2 bar are different and P bar is different. Okay, so let me just highlight this part. Is it clear? So after you get the z-test statistic, then you find the critical value approach or the p-value approach, whichever approach you guys want to follow, and then you make the decision whether to reject or do not reject. Okay, in this case we could not reject because it didn't fall in the rejection region. Okay, and if it's a two-tailed, then p-value you always have to multiply by 2, right? This you guys have done in the previous chapter. I have covered in our lecture videos as well, so if you watched them, it's pretty straightforward. Can't we all take the Zoom call at the same time? Can't we all take the exam on Zoom call at the same time? And what are the unlimited? No, it's not unlimited. You have 2 hours 30 minutes. What happened here? Once you log into your exam, the clock starts automatically. Okay, 55 questions, multiple choice format. Okay.
Right, I think they meant that instead of taking on the webcam, just take it on Zoom call with you as the proctor.
Oh, no, you can't do that. Yes, you have to proctor there, because that's how the system is set up. Okay. It's flexible, and by the way, like you guys will have different questions maybe, but the similar format. Okay, so don't. I mean, I know you guys won't do any like cheating or anything. I'm assuming all of you guys are going to be like ethical, and the camera will be on. So if you do some unethical things, it will be get recorded. So yeah. Um, Pretty much it's flexible, like it's February 22nd 9 a.m. to February 23rd 11:59 p.m. Once you start the exam, you have to finish it within 2 hours and 30 minutes. You cannot be like, oh, can I submit it like tomorrow because I started on 22nd of February. No, once you start the exam, you already commit to the exam. Okay, so like, and you cannot leave in between the exam. Like you cannot take like, oh, let me go out and like half an hour later come back and finish the exam, because the camera will be on, so don't do that, because the department might cancel your sounds hard. No, it's like an exam, like it's pretty much like an exam. So that's why the flexibility is there. Like you take your own time whenever it's convenient for you to take. Some people like to take in the afternoon, some people like in the morning, some people like to take it in the night time. Okay, uh, like around 10 or something. But don't start the exam too late, then you won't have enough time, right?
Excuse me?
Yes.
Did you say that the exam was open until the 23rd? I heard you.
Yes, it's a 2 days. So February 22nd to 23rd. So let me check the syllabus again. Okay, it's
Yeah, I checked it. I think it was yesterday, and I thought it was the 20th to 21st.
okay. Let me just check the syllabus. Okay, I don't want to give you guys wrong information. Yeah, let's see, 20th to 21st, or is it 20?
I'm looking at 22 to 23.
Yeah, let me look at the syllabus. Okay, so yeah, thank you for asking the question. Yeah, I need to double confirm that. February 22nd 9 a.m. it starts, and it ends February 23rd 11:59 p.m. Okay,
Okay, sorry about that.
no worries, no worries about it. Yes, it's good, always good to confirm, because yeah, same, and he gave us, but if it's, we had only 25 questions. Yeah, see, different subject has different requirements. BA3400, we have to cover a lot of concepts. So that's why we need more questions here. So pretty much that's what we need to do. Also, confidence interval problem. You guys need to know this formula as well. So let me just continue. So confidence interval problem, this question will also be there. There is a question regarding this. So this problem, control E. So confidence interval, right? There is lower bound and upper bound. So lower bound, then upper bound. Okay. What is this portion? This is called the point estimate, right? If you watched my lecture videos. And what is this part? This part is the margin of error. So if I ask you guys find the margin of error, I'm actually only talking about this portion. Okay, there is actually a multiple choice question asking about the margin of error and the point estimate. So in the confidence interval, there will be a problem like this. There could be like a degree of freedom, but if its sigma is unknown. But I told you guys I'm not going to ask a complicated calculation in the exam. So I'm trying to make it as simple as possible, okay, given the limitation. Okay, so for proportion as well, we have confidence interval too. So that's for the part 2 is the confidence interval for proportions. So for proportions, it will be this formula. All right. So this is for the means. So confidence interval for the means. And the proportion, let me use the snapshot, right? So confidence interval for proportions. Oh, I already did it here. Oh, okay. Similarly, this is point estimate. And this is the margin of error. Okay. So this is margin of error for that one. So let's look at a worked example. So this is the worked example, page 24 of chapter 10. I will upload the slides, so don't worry, you can review my video and go through the slides and do some problems here. So page 24, important problem. I won't give the exact same question, but the numbers would be different and the question would be slightly different, okay? But the style is similar. I can ask you what's the lower bound and what's the upper bound. So this is important. So this formula also you need to know. Okay. If you subtract from the margin of error, that gives you the lower bound. Point estimate minus the margin of error. So very important formula here too. So let's. So oh, okay, it didn't. Okay, maybe now it will go. Yes. Okay. So very important formula. Let me highlight this as well. Use a different color. This should be in your cheat sheet. Basically, this should be. Another thing is if it doesn't cross 0, the number line, that means it is significantly different from 0, right? But if it overlaps 0, then it is not significant or not significantly different from 0. So here our upper and lower bound is different from 0. It's clear from this question. Okay, in the exam maybe it's not, who knows, like which type of question I have given. So this is the other question in page 25. Here it is not, because it overlaps the number line 0, right? What do I mean by that is, see, it contains 0, so there is no statistically difference between mean overtime hours by these two populations. So that's about chapter 10, and I have given 2 questions about proportions, and chapter 9 pretty much everything I covered. Are there any questions? I don't know, under modules or gates. It will be in the quizzes section. You have to install the lockdown browser. Okay, so install lockdown browser. Okay, that's important thing. Let me show you how it looks in my on my end actually. So if you see, I have a lockdown browser here. I have a quiz section here. So first install the lockdown browser. Go to your quiz section. Okay, from the lockdown browser. Okay, you will see there is a practice test. It requires webcam as well. So take the practice test. It's ungraded, and it's only 4 questions, and it will give you idea that how the exam looks like. Okay, later on February 22nd, you will see that midterm 1 will pop up. and you have to log in through the lockdown browser. Okay, only then go to the quiz section, you will see midterm 1, and that's how you will take the test. Okay, is that clear? Okay, so I wish you guys all the best, and some of you guys are here for the homework problems. Jai, I think you have chapter 10, and somebody have a problem with chapter 9 assignment, right? So those,
That was me.
okay, so those of you who have already attended this session, if you want to hang out for the chapter 9 and chapter 10 assignment, you can stay here. Okay, so where is, okay, so Jai, do you want me to cover your problem first, or Hala? I think Hala was there.
Yeah, I just couldn't find the p-value. Every single time, like I used a scientific calculator. I didn't try doing it by hand, but I used the scientific calculator and I just kept getting it wrong and I didn't know why.
Which one? The MindTap problem, right?
Yeah, it was on chapter 9 assignments. It was the last question though.
Okay, let me go to that section. Okay, just give me a minute. Chapter 9. This question will not be similar to MindTap. No, it will be like the lectures. How we have in the lectures. Last question means the chapter 9 assignment or the 9.5 activity A. Hala, you there?
The chapter 9 assignment, the one under.
Oh, the one under, okay.
The 50.1, yeah.
Let me try to log into my account from my other screen. Okay, just give me a minute there. So which problem you are facing difficulty?
I think it was number 9 or 10.
Number 9.
No, this one, the P0, I think the P was 0. I think it was number 10.
Oh, this one was about the population
Yeah.
proportion.
Yeah.
So you can go to the data file. Yeah, it's taking some time to load in my screen here. So you have to calculate the percentages of no and yes, like the P here. Did you do that in your part?
No.
Oh, yeah, you have to do that in that case. So that will give you the answer actually. So here there are 101, so that means 100 observations. So you need to calculate the number of no and yes. So there is a formula in Excel. Okay, so let me use that formula here. Countif. So you can use Countif functions to calculate the number of no and yes. So let's look at this. I think, did I give you guys that formula? Countif from A1 to A101, right? What was the last one? 101. Let's say no. No is small. Or maybe count function. Let's see. Oh, I know where is the mistake. A100 is Countif. Yeah. So there are total no is 87. So 87 out of 100. Yes, I got it. So 87 no's. So yes would be 13 then, right? Because there are total 100 observations, I think. So from 2 to how many? Okay. So now it's pretty easy. So you can use that to solve the problem. Okay.
Okay, thank you.
Yes, you're welcome. What about Jai?
Yeah, my question was for. I'm pulling it up real quick.
Your one was for chapter 10, I think.
Yeah, it was 10.2. It was the first question, the first graded question, and my question that I need help on was C. Everything else I got right,
Right.
but for C, I got it wrong. And I followed the Excel video that was given. And
Okay.
you're supposed to like.
Oh, sorry. This is private stuff. Yeah. Chapter 10. So let me go to modules. Yeah, I shouldn't have clicked grade because then everyone will see everyone's grade. Okay, that's not. Yeah, I closed it before it popped. So chapter 10 to 2A. This one, right?
Yes, I believe it's 2A. Yep.
Wait, that's due on the 21st, right?
Yes, this is due late, but it's okay. I can show because my question will be different from your guys, okay? It's not going to be same. So sometimes you will say that professor, my answer didn't match with yours. Of course it won't match because the numbers are different. Okay, so let me open my spreadsheet. So open spreadsheet. So let's read the question here. So math scores 514, okay. Okay. Mean for college. So it's very easy. Mean for college. It should be equals to average from A1 to A17. 524. Okay. High school mean is average from B1 to B13, right? All right. Difference is basically simply the point estimate. So this minus this 50. What about the other thing? Oh, okay. So this one, stat scores on the highest level attended by the test takers parents are provided. Our research hypothesis was that yes, if parents have higher education, they will have a higher. Okay, overall stat score was 514. So it should be greater or equal to, no, not this one, this one. What's the hypothesis that the let me see, population mean math score of parents college graduate had the show higher population means if they've attended a higher education. So mu1 is the college graduate parents, okay, and mu2 is the high school graduates. So college graduate minus this one is greater than 0, and this one would be the other way around, right? Yes. What is
That's
the
what.
yes? What is the point estimate of the difference between the means for the two population proportions? So the difference is 50 for my example, right? Did you get the same numbers for your problem? Because your college and high school numbers might vary.
Mine was different. My point estimate was 102.
Okay, for me it is 50. Okay, 50 if points higher, if they are college graduate. Okay, so the problem you faced is the t and p value, right? So
It
the
was just all three of those. It was the t value, p value, and the degrees of freedom. I used this part C right here. I did what this said to do.
yes, it was like unequal variances. You did this one, right?
Yes, yeah. I plugged in all the numbers. I followed the video, and then it usually pops up. It tells you what the answers are. Like it tells you what the degrees of freedom is and everything, so I don't have to calculate it.
Okay,
I just
so
typed in the answers, but it said it was wrong, so I don't.
so variable range 1, see the you also have to select the first college as well. Maybe what you did, I think you did selected from 2 to 17, but you should select from 1 to 17.
Okay,
Similar,
yeah, I did it from two, so yeah, I didn't do one.
yes, variable 2 also you have to select from 1 to 13, and the hypothesis mean difference is your difference. So my difference is 50, your would be different, right? So let's put 50 here. And what is the significance level for your case? My case, did they tell the significance difference? 0.05, right? So
Yeah,
0.0.
mine's 0.05.
Okay. So my one is also 0.05. So then I put the output here and press OK. See, my degree of freedom is 24. Um, so let's put that there. Where is it? Is it maybe this one, right? Degree of freedom 24. T value for my case, the one uh, T value too simple, assuming, is it giving me wrong values here as well? Let me just check.
I think in the video for the hypothesized mean difference, they said to put 0. I don't know if that was for their specific problem, so it should be different from ours. I don't know.
No, in the video, let's look at the video, the last part. Just look at the formula, I think.
5 is indicated as 0.05. This value.
So T stat, I don't know why it's showing 0 here in my case, the t-stat. See, this is the problem with the. Okay, let's see if it's 0 or not. Maybe my one is 0. All right. Let's and they did one tail is 0.02. For us, it's one tail is 0.5, 0.50.
But in her video, I think her point estimate was like 63. But for the mean difference, she put 0 when she plugged it into that chart. If you can look at that, see how her difference between the means is 63. But on the right side, when she plugged in the hypothesized mean value, I think she plugged in 0.
Oh, right. Because yes, in the hypothesized, right.
That's why.
Yes. Hypothesized mean, yeah, hypothesized one. It's see the Excel doesn't even change. I think. Let me redo it again.
Sure.
Yep. Unequal variances, variable 1. Range is, you should select the whole thing, okay? And this one also the whole thing, because the average we did the whole thing. So hypothesis is 0, alpha 0, output range, put it here, D8, okay. I think once you made a mistake, it doesn't change. Why?
You have to highlight it and then delete it. You have to highlight that from D8 to D20 or whatever. You have to highlight that and then delete that.
Yeah, delete it.
On the Excel.
Let me just delete this. Okay, let's see. Still it's giving me 0. That's weird. No. Now actually, yes, 1.8903 if it's 4 decimal places, right? 1.8903. Degree of freedom should be 24. Yes, same. P-value 0.0354. So 0.0354. So it's less than our alpha, so we can reject, right? So yes, let's see. Yeah, it's correct on my end. So I think the mistake you might have made, if you choose from A2, right? Let's see if the value changes or not on B2 here, all right? And then let me delete this. Oh, this one is from this one B. Select this part. Why this Excel is like making. Okay, manually maybe write it. Okay, B2 to dollar, B $13. Output range. Yes. Yeah, so you will get like wrong values, basically. So I think the common mistake, because I have seen students select from 2 because they think that this is the number. I think now if you do it you choose 1 for both case, you will get the correct value, because
I was doing everything right, so I was confused as to why that was wrong. Okay, that makes sense then.
yeah. And the other thing is, see, this is the Excel way of doing things, right? I have also sent you if you want to do it manually, So the manually you can solve it, the solution that I have already sent you. If you want to do it by hand, so how you want to do it by hand, you have to individually do all of the things. So maybe students can see it as well. So manually, if you guys want to do you have to find the S1, which is sum of xi minus x bar square over n1 minus 1, right? So you have the S1 for the college, and for the school you have different too, right? S2. So that's xi minus this one x1 bar, so that would be x2 bar square. Okay. And this would be n2 minus 1. So you have to individually sum all the values. So it's like 464 minus 524. So 464 minus 524 square plus 528 minus 524 square plus, so for all these 16 parts you do up to 16, right, for the last term. And then n1, total number of n is here what, 17 or 16, so 16 minus 1, right? So that's for part 1 s1. Then for part 2, what is our x1? X1 is 552. So the 552 minus their mean is 474. So 474 square plus 528 minus 474. So 528 minus 474 square. You have to do it for all the 13 terms. 1, 2, 3, 4 till 13, right? And then not 13, 12 terms. So 12 minus 1. Because total terms are 12. Okay. So once you find S1 and S2, then you can find the degree of freedom, right? Or because the degree of freedom is, this one is tedious, which is that formula, and I didn't even ask that in the exam. So where is that formula? So it's very tedious to do it that way.
Right.
This one, right? So this one you can use. Once you have found S1, once you have found S2, then you use this one. That will give you degree of freedom. Once you have degree of freedom, then you can find the t-statistics, p-value, everything.
Right.
Yeah, but pretty complicated. I don't want you guys to do it this
That's
way.
fine.
Yes. So any other questions, guys? Was it helpful, the review? I hope it did. 12, 13 people are here already. That's great. Any other questions? So best of luck, and I will upload the videos. I have a question. Well, we used Excel to find the answer, but in lockdown browser, I'm not going to ask any Excel questions in the exam. But let's say if I ask you a p-value of test statistic, then you can write like t.dist, something like this, right? Actually, let me show you the formula sheet where I wrote. Okay, Control E. Yes, you have to calculate it in this way. Let me give you an example. Let's say I say t test statistic equals to 2.3. I give you degree of freedom is 24. What is the p-value? And I tell you it's an upper tail test. So then the p-value would be what? You can write p-value equals to t.dist, since it's an upper tail, dot rt, then you write the test statistics 2.31. Okay, let me move the screen on that side too a little bit. Oops. Oh my, I don't know why it's stuck here. Okay. (2.31), then degree of freedom is 24, right? 24. So this would be the p-value. You don't even need Excel. Got it?
Yep.
I got it. I think Ufnan, you asked the question. So to calculate the p-value, you don't even need Excel. You just write that one. Yes, you just write the equation, exactly. In fact, the equation will be given in the multiple choice question. You just have to pick the correct equation. Maybe this is choice B, let's say, in the multiple choice question. Something like that. So thank you guys. So let's end here. Best of luck to all of you. And yeah, I will post some multiple choice questions for chapter 9 and chapter 10. Yes. So yeah, all the best. Stay safe. Okay, don't travel too much outside. Need to stay home too. And if you guys have any other problems, do let me know. Okay. So thank you, everyone. Have a good one. Yes. Bye bye, guys. Let me sign out now. Where's the Zoom? Let's first. So end the session.